Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases. Welcome to episode 18. We'll cover questions 86 to 90 in this episode. For questions 1 to 85, please refer to previous episodes of the series. Let's get started. The main and secondary data centers of a business are located 500 miles apart and are linked through high-speed fiber optic cable. For mission-critical workload, the organization requires a highly available secure network link between its data centers and a AWS VPC. A solution architect must choose connectivity solution that is resilient as possible. Which solution satisfies these criteria? So what we have in terms of problem definition here, we have a couple of data centers. There is a main data center and a secondary data center. They're located quite far. 500 miles is distance between them. And they're linked through high-speed fiber optic cable. Organization require a highly available and a secure network link between its data center and an AWS VPC. So what should be the solution? And we have few options here. Let's go through each of them one by one. So the first one says, let's have two AWS direct connections from the primary data center terminating at the two direct connect location on two separate devices. Now, direct connect is a good solution. And obviously you can see direct connect is across all of the options. But this one will create a single point of failure at the secondary data center, single connection. So we have two direct connections from primary data center terminating at the two direct connections on two separate devices. So primary is fine. We have a lot of resiliency here. But what about secondary data center? That doesn't have reinforced connectivity. So this one is not perfect. Let's see what do we have in option B. It says a single direct connect connection from each of the primary and secondary data center terminating at one direct connect location at the same device, on the same device. Now, this obviously is not as good as even option A. Single connection means we don't have any redundancy. So any outage would cause problems. So option B is also wrong. Option 2 says, let's have single direct connect connection from each of primary and secondary data center, and it will terminate at one direct connect location on two separate devices. So at least in the destination, you have two separate devices, which is good. But from source perspective, you still have both the primary and secondary data centers having one single direct connect connection. So option D is also wrong. And that leaves us with option C, which says two AWS direct connect connection from each primary and secondary, which is great. So both primary and secondary have redundancy built in for higher connectivity, and both will end at two direct connect locations. So you have 2 into 2, 4 possible options by which you can have connectivity from a data center to AWS. So from each of the data center, you are terminating on two direct connect location on two separate devices. So that gives you high amount of resiliency, and this is the correct answer for this particular question. Let's do a deeper dive on the characteristics of this solution. So first one, obviously you are getting dual connectivity from each data center, which is what we saw. We have redundancy built in this solution. Both primary and secondary are having two direct connections from each of the location. And then the second one is not just source, but the destination also we have some redundancy because now we have two direct connection at the other end and they're on two different devices. Question number 87. A dynamic website of a business is hosted on premises in United States. The firm is expanding throughout Europe and want to reduce site loading speed for new European visitors. The backbone of the website must stay in United States. A few days from now, the product will be introduced and an instant answer is required. What recommendation should the architect make? So let's look at the problem description here. What do we have here is we have a dynamic website and it's on premises in United States, but it is expanding throughout Europe. So we are going to have people logging into this particular website from Europe, and that's going to so we have visitors logging onto this website from Europe, and we want good speed for them. However, the backbone of the website must remain in United States. You do not have an option to have some sort of installation nearer Europe. Now, there is going to be a product introduced soon, and obviously that product is going to be popular in Europe, and we want to make sure that there is no latency for European users for accessing this product. So let's look at what will be the solution in this case. Generally, this kind of problem is a classic situation for Amazon S3 and CloudFront, but you need to be really careful here. It is a dynamic website. It is not a static website, so there is no S3 needed, and that's ruled out. However, CloudFront is still a possibility. One of the website can remain in United States, and we can have a CloudFront deployment, and that CloudFront through its edge locations across the global network and European network in this particular case will be able to provide low latency for European users. So I think that will be my solution in this case. We don't need S3 because there is no static content, but Amazon CloudFront will still do the job. It is all about providing low latency, and CloudFront is sufficient. Let's see what options we have in the given problem, and let's figure out if we have this particular solution over there. As I can see, there is an option which includes CloudFront, which is option C. Let's go through each of the option and see why they are incorrect. So option A says launch an EC2 instance in US East 1 and migrate the site to it. Now, if you're talking about migrating entire website to an EC2 instance, it first of all wouldn't improve loading time on European users. So latency will still be high. The main problem that we have here is the European users will try to access this US website and will currently have latency. And whether you deploy it in EC2 or somewhere else, as long as it's in US, because of the geographical distance, there will be latency for European users. So option A is absolutely wrong. The next one says option B, move the website to Amazon S3, use cross-region replication between the regions. Now, this is not a static website, so there is no benefit of moving the website to S3. Cross-region replication won't benefit users in terms of low latency. That will help in case of disaster recovery, but that's not what we are trying to solve here. So option B is incorrect. Option D says, let's use Amazon Route 53 geo proximity routing policy pointing to on-premises servers. So Route 53 can route users to closest resources, but it won't be able to cache content for low latency. You need some other solution for that, which is CloudFront. So option D is incorrect. On its own, Route 53 is not going to do anything to help with the low latency. What we are left with then is option C. It says use Amazon CloudFront with a custom origin pointing to the on-premises service. So this approach is very fast and effective solution. And obviously it will address the immediate need for improved website performance for European users. And obviously you have tight deadline as well. The product is going to be launched very soon, so you can't make a lot of changes. So this is a well contained solution which can be delivered very quickly without impacting overall solution architecture. So that's our answer. Option C, use of CloudFront. That's it on this question. Let's move on to the next question. Question 88. A corporation used a AWS Direct Connect connection to copy 1 petabyte of data from a co-location facility to an Amazon S3 bucket in the US East 1 region. The business now wishes to replicate the data in another S3 bucket located in West 2 region. AWS Snowball is not permitted at the co-location facility. What should a solution architect suggest as a means of achieving this? We have a scenario where a corporation used a direct connect connection to copy 1 petabyte of data. Now business want to replicate the data in another S3 bucket, which is located into West 2 region. First, the data was copied in a bucket in East 1 region. Now it needs to go to West 2 region. You're not allowed to use any Snowball in this case. What we have here is very classic application of cross-region replication. You have some data in S3 bucket in a particular region. You need to copy it across to another region. And that's where cross-region replication comes into picture. And we can also see option D is also covering this particular option. And that's the answer according to me. Let's look at other options to see why they're incorrect. So the first one is option A. It says, let's order a Snowball edge device. And we have been told it is not allowed. So AWS Snowball is not permitted. So we can't use this solution. Even if it is permitted, the data is already in AWS. So what is the purpose of then a Snowball device in this particular case? This is a wrong answer. Let's look at option B, transfer content from source S3 bucket to target S3 bucket using S3 console. So option B, transferring content from one source S3 bucket to target S3 bucket using S3 console would be a manual and a time consuming process. The data size that we have is 1 petabyte. This is a very inefficient solution. So option B is technically possible, but it's not correct in terms of efficiency. So option B is ruled out. We have option C. It says, let's use Amazon S3 sync command to copy data from source bucket to destination bucket. Using a sync command would also involve manual intervention and may not be as efficient, similar to option B. We need something which is a purpose-built solution, and that's the key. Every time you need to provide a solution, you need to use an AWS service that is purpose built for that. And for most scenarios, you always have a specialized service. In case you do not have a specialized service, you should go for combination of specialized services to keep the operational overhead minimum, to keep the cost minimum, unless there is an explicit mention of exclusion of those requirements. So option D is the correct service for this particular scenario. We'll use cross-region replication to copy objects from one S3 bucket to another S3 bucket in different region. So that's our answer. Let's do a deeper dive on cross-region replication. So what do we get in terms of cross-region replication? So first of all, automatic replication. Once this configuration is done, the data replication process happens automatically. We don't need any manual intervention or any other tools to do this job. Now, you saw option B and C, both were trying to use some ad hoc processes, manual processes, which obviously needs manual intervention and causes additional operational overhead. So that's the main advantage. Then data consistency. By using this, the data is consistent across the buckets. So that's an obvious, and that's a important requirement for a process which is copying data from one location to another. It's very efficient. As we have seen, data transfer is happening between region and it minimizes the network data cost. And obviously you are not leaving the AWS infrastructure as well. That helps with the efficiency and keeping the cost low. Scalability, this is a very scalable solution. You can do large scale data replication without any impact to performance. So if you have in exam any question around copying data from one S3 bucket to another S3 bucket across the regions, you should go for a solution which includes cross-region replication as the key component of that answer. That's it on this question. Let's move on to the next question.
Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you've not already done it. Thank you.
Question number 89. The application of a business is hosted on Amazon EC2 instance that are part of an auto-scaling group behind an elastic load balancer. Each year, the firm predicts a rise in traffic over a holiday based on the application's history. The solution architect must develop a plan to guarantee that auto-scaling group raises capacity proactively in order to minimize any effect on application user performance. Which solution will satisfy these criteria? Let's look at what are the keywords here. So we have a set of EC2 instances in an auto-scaling group. We have an elastic load balancer. And the scenario here is we have a holiday period where the firm is expected to get high amount of traffic, and we need a solution to minimize any effect of increased traffic on user performance. So what we have here is we have 4 options again, and let's see which one are obvious wrongs. Now, first one, it says, let's create an Amazon CloudWatch alarm to scale up EC2 instance when CPU utilization exceeds 90%. Now, this is definitely not proactive. This is very reactive. So we are expecting CPU utilization to hit 90% and then scale up EC2 instances. I think by this time, if you're hitting CPU utilization to 90%, the application will obviously start struggling and start impacting users. It will most likely be too late to increase the power and number of EC2 instances in the auto-scaling group. So this is not a correct solution. This is too reactive and too late as well in terms of when we are kicking in auto-scaling. I will skip option 2, but let me see what option C says. That one looks incorrect option to me. It says increase the minimum and maximum number of EC2 instances in the auto-scaling group during the peak demand. Now, when you increase the minimum and maximum number of auto scaling group, that is still relying on auto scaling group to react to the increased traffic, which may result in performance degradation before the instances are launched. So this doesn't look like a correct option to me. It's not proactive, first of all. If you know that you're going to hit the peak demand, you should anticipate that demand. And I would ideally do a scheduled resourcing and schedule auto scaling action. But let's park that for now. Option C is wrong. Let's see what else we have. I think option D is also wrong. It says configure a SNS notification to send alerts when there are auto scaling EC2 instance launch events. Now, configuring SNS is okay for monitoring, but it does not address the requirement. The requirement is we need to add number of EC2 instances, and we need some solution where whenever there is high traffic, which in a period, we want to kick in auto scaling to increase the number of instances. And obviously, when the traffic goes down, we want to kick in to reduce the number of instances. And it's a wrong option. That leaves us with option B. So option A is incorrect. Option C is incorrect. Option D is incorrect based on what we just discussed. So that leaves us with option B. It says, let's create a recurring schedule action to scale up the auto scaling group before the expected period of peak demand. And that appears to be correct answer because we know when this is going to happen. When this rise in traffic is expected, we should create a scheduled action and recurring one so that every time this happens, if there are multiple holidays, we can cater to that. So that's the correct answer, option B. Let me do a deeper dive on how this option is the correct one. The first one, obviously, the whole key point of this particular solution is proactive scaling. So when we are scheduling actions to allow auto scaling group to scale out resources proactively, ensuring the additional capacity is available before the actual traffic spike occurs. So we are not waiting for the spike to occur. We are selecting the period and maybe doing it slightly earlier before the expected traffic rise. And that makes it proactive. That protects the users from degradation in application performance, predicting the capacity planning. Obviously, not just timing, it's also we need this option allows us to predict the increased traffic capacity based on historical data, depending on your last year's performances, and maybe you add some buffer to it. And you could then schedule the right capacity to which you should be able to increase the auto scaling action in terms of addition of EC2 instances when the high peak hits your application. So that's the second part. So it's not just when, but it's how much you are able to control with this option. And obviously, you can make it a recurring action. So this scheduled action can be configured to run automatically on a recurring basis. And that means you can have multiple holiday periods and you don't need any manual intervention during those. So as long as you know, okay, you have a Black Friday window, you have a Christmas window, you have something around some other event, you can schedule all those windows as long as you are when element and what element is accurate enough, you do not need any manual intervention. And all of this means you're going to get cost optimization because now neither you are over provisioning and neither you are under provisioning. Over provisioning, you're not over provisioning because you are doing it based on your historical data that you have. So that protects you from unnecessarily spending high amount of capacity to protect the user performance. So you are doing the right job, optimizing the overall usage and thus reducing or optimizing the cost as well. That's the overall explanation of this particular option. That's it on this question. Let's move on to the next question. Question number 90. A business utilizes application load balancers across many AWS regions. The LB experiences fluctuating traffic through the year. The company's networking personnel must enable connections by allowing the LB's IP addresses over the on-premises firewall. Which solution is the most scalable and requires least amount of setup changes? The business has application load balancers across many AWS regions, and we have fluctuating traffic throughout the year. Company's network personnel must enable connections by allowing ALB's IP addresses over the on-premises firewall, and we want a scalable solution with least amount of setup changes. So we want something that is possibly purpose-built and easy to configure solution. Let's see what options we have and which options are incorrect and what does that leaves in terms of correct option. So option one is around Lambda script. Let's write a Lambda script to get IP addresses of ALBs in different regions and update the on-premises firewalls rules to allow IP addresses on the LBs. Now, this means you'll have to write the scripts. and this means manual intervention and a lot of setup changes. So this is going to be very heavy in terms of complexity as well as management overhead and operational overhead. So this is not a correct answer according to me. So we rule that out. The second option says let's migrate all ALBs in different region to the network load balancers. Update the on-premises firewalls rules to allow elastic IP addresses to all NLBs. Now we do not want to do a lot of changes. And this option says migrate all ALBs to NLBs. And this may not be feasible and desirable depending on applications requirement. Additionally, managing elastic IPs on the NLBs in different regions will add definitely complexity. And I believe we should have some better solution, and that's what we are coming to, something that is purpose built for this kind of situation. But we rule this particular option out right now. I will skip C and move on to D because according to me, D is also wrong. So D says let's launch an NLB in one region, register the private addresses of the LB in different regions with the NLB, update the on-premises firewalls rule to allow elastic IP address attached to NLB. Now this is going to be a single point of failure with the central NLB. Registering private ALBs, IPs from various regions with a single NLB is also very complex, and firewall rules would still need updating. And that means we have manual overhead over there as well. So this solution will work, but again, it fails on amount of setup changes. Operational overhead is pretty high on this. And that leaves us with option C. And option C says, let's launch AWS Global Accelerator, register the ALBs in different regions to the accelerator, update the on-premises firewalls rule to allow static IP addresses associated with the accelerator. Now, AWS Global Accelerator is the way to go in this particular scenario, and let's see why this particular option is suitable. First one is scalability. Global Accelerator provides a single entry point to all ALBs across region. This eliminates the need to manage individual ALB IP addresses in the firewall rule, simplifying future scaling of ALBs. So this is your single entry point, and you don't have to worry about IP addresses of other ALBs. So that's the key and unique selling point. The second aspect is setup changes. Obviously, setup changes are minimal in this case. You only need to update the firewall rule to allow static IP address of the global accelerator, and behind global accelerator, all your ALBs are already covered. So this minimizes the change on on-premises side, and that makes this solution a attractive one. So that's it on this particular question. I believe this was the last question of this episode. I'll see you in the next episode of this series soon. Thank you. This is Exam Tricks and Tips. You're watching the AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.